Okay, so we're going to just summarize everything we know about orbitals. Okay, so the, atomic orbitals. So these are an orbital is a shape that an electron charge cloud is allowed to have. And so let's just talk about, if we talk about in the first principal quantum shell, we only have the s suborbital. In the second principle, so the second shell out, you have S, and then you also have P. In the third, you have S, P, and then you have D. And in the fourth, you have another orbital. That's the F. That's possible. S, P, D, and F. Okay, so just remind how many different S orbitals have we got? So S, there is just let's write that down. So for S, P, D, F. There's only one s orbital. So you can fit 2 electrons in there. There are 3 different p orbitals, all at right angles to each other. So you've got 6 electrons in there. D, we've seen there are 5 possible orbitals. And so you can probably guess that F is going to have 7 possible orbitals. And there is another, after that there's G, but that never gets occupied because there's never enough electrons in any of the atoms that we have. But nevertheless, it's still there. But anyway, we just worry up to F. Okay, so I'm going to use this little color coding that I've set here. So if it's in principal quantum shell, it's going to be yellow. So hydrogen, where's the last electron? Well, it's in 1s, isn't it? So I'm going to put an S there. Helium, the last electron is 1s. Now that's full up. When we go to lithium, we now have to go to quantum shell 2, and so that's in, you've got an electron in 2s there. In beryllium, like 2s, and then when you get to boron, you have to start filling up the p subshell. So that's going to be p, and there's room for 6 electrons there. And when you get to neon, that's full up, and then we have to start filling up 3s. So I'll change color. So this is 3s. And when 3s is full up, we fill up 3p. Room for 6 electrons there. Chlorine has got 5 electrons. Argon is full up, so that's p. Then we start filling up the 4th quantum shell. Potassium is 4s. And that's when we gets a bit harder then, doesn't it? Because 4s is actually lower in energy than 3d. So then you sort of go back a little bit to 3d. So I'll change color back to so this is 3d, not 4d, it's 3d there. And the same, and you've got room for 10 electrons there. And by the time you get to zinc, the D is full up, 3d, and then you start filling up 4p. So I need to go to green because it's in the 4th quantum shell. So that's p there. And when you get to krypton, that's full up. Then we go to the 5th. Rubidium is the 5th quantum shell, so purple. So that's 5s. The electron goes in there. Strontium, you've got 2 electrons in 5s. Then you go back to, once 5s is full up, you go up to filling 4d. So I need to change my color to green. So then the D, and then you've got 10 electrons in 4d. When you get to cadmium, that is full up. Then you have to start filling up 5p, sorry. So this is 5p is being filled up here. Iodine's got 5 electrons in 5p, xenon's got 6. Then, I'm running out of colors here, so I'm going to have to, so this is going to be quantum shell 6 now. Quantum shell 6, so we have got that 6s is filled up there. 6s is filled up there. Now we are going to fill up that 6s, go to 5d. So here's 5d. the right color for that. So that's 5D. Now that's when it gets a bit trickiest, because then you start filling up, you go to here. So all that block of elements in here, see them, all that lot, they squeeze into that little gap there. Can you see there's a gap between the atomic number there, you know, between so that's where the number, that's number 56, that would go in there. So that is going to be filling up the F orbital, and what is that's going to be 4F, so I've got to do that in green. So this is all 4F here. And you've got room to 7 orbitals in the F, so you've got room for 14 electrons in there. That's when that's filled up. So then, so we did have a 1,5D there, didn't we, lanthanum? So then you start filling up the other 5D. I think I've got slightly the wrong shade of purple there. Let's make do with that. Okay, so then you start filling up these. This is 5D. 5D is full up. So then we have to start filling up 6P. So that's got to be in that color. Right, now I'm going to have to go to 7. So I need another color for 7. So what can I have for that? What should we have? We'll have that gold color, shall we? Okay. So this is quantum shell 7. So that's 7S there. Then we go back to 6D. So that should be there. So we just have 1D, and then we start filling up 5F. So 5F should be purple. That's all the 5Fs get filled up. All 14 spaces. When that's filled up, then we go back to filling up 6D. Okay, and by the time we get down to these elements, they're all very big, and they're mostly synthetic. They don't exist naturally, and they're all radioactive and stuff, and the chemistry is not really that important to us anyway. And generally speaking, we are just concerned that up to the end here, like krypton is probably the last element that we're really interested in. So that one there. Right, so you can see this is where the names come from. You have this block here is called that's the S block, because that's the last shell to be filled. This block here is called the D block. And obviously this bit here is called the P block. And all these radioactive ones that we don't really know much about they're the F block elements. Okay, so that's probably all we're going to do on atomic orbitals for the moment.